We spoke about this on Friday in class when we talked about the fact that slope is, no matter what, it is always the change in y over the change in x, or as written symbolically, dy dx, or in earth science, change in y over change in x, or delta y over delta x. Same concept, same idea. So slope is always going to be, regardless of the equation, the change in y over the change in x. So in the case of when you had the y equals x squared in those homework questions, it was easy. You just did the slope and said, okay, I'm going to do the derivative, and it is the slope. That's the slope of every point on that equation. But when it's written as x equals y squared, and we're going to look at this more in the video tonight that you're supposed to watch, as well as just in the future of this chapter, what happens when it's not y equals, that we have to make some adjustments for that. All right, and so as we noticed on this particular question, we noticed that, okay, when we did the derivative, when we had the dx over dy, and we had the 2y, it changed. We've used the y value and we used the point, and we then had to do the reciprocal. That's really what tonight's video is going to be all about. So the idea is still, it's dy dx is our slope. We need to know that. So let's just look at a little bit more of, I'm going to kind of scroll down here. What about when you have other letters? What happens when you have other letters like U's and V's and Z's and T's and all of that stuff? And so we're going to look at a few examples of that today, especially. So how do you do the derivative of that? Well, let's start with this. Y equals x cubed. What would be the derivative of y equals x cubed? 3x squared. And that would give me dy dx, the derivative of y in respect to x, that's what it means verbally, is 3x squared. Okay, let's look at the next one. It says u equals v cubed. Now, probably anybody in here could tell me what the derivative is. You would basically say what? 3v squared, no problem. But in notation, what this looks like is du, the derivative of u, and what's the letter it's in respect to? dv. And so that would still be 3v squared. How about the next one? Z equals t cubed. How would we write that? dz over dt equals 3t squared. And so for the same reason, when we look at x equals, it doesn't matter what the letter, this would be dx over dy equals 3y squared. Doesn't that make sense? Does that follow through? And we're going to be moving towards, you know how in the past we've even reformatted some of these equations so that it says y equals and then done its derivative, where we can leave even the question like you saw in your homework with the x squared plus y squared equals 169. We're actually going to do questions where you don't even have to get that equal to y. We can do the derivative and find the slope without even moving anything. We'll leave it just like that and do the derivative. And that's where we're heading in the next couple of days, called implicit differentiation. All right, well, let's look at some examples. So how do I find the slope when it says, all right, x equals y squared plus 7y at that point? There's a couple options. I'm going to do the one today that probably is most natural for many of you, which is just we're going to find its derivative right now, as it is, and we're going to work with what we've got. And we'll get it in the form of dy dx. But tonight's video talks about what if you can't take the derivative? What if you can't do this derivative? But you could of its inverse, and it looks at it. Tonight's video is probably one of the most important, so please make sure that you look at that. So let's do this example. So what I'm going to do is find the slope of this. Again, when you do the derivative, what will this look like on the left side? D what? Dx over dy. All right, and what is the derivative of that first part? 2y plus 7. Any questions about that? If I want to know the slope at that point, then all that I need to do is plug in which value, the 18 or the 2? The 2, because that's the y, and this says 2y. So that would mean I'm going to do 2 times 2 plus 7. And that would mean it's 11. But as we talked about on Friday, and as again we're mentioning today, slope is not dx over dy, but is dy over dx. So it becomes absolutely critical that you recognize that it is the change in y over change in x. So how am I going to get what that slope actually is? So it would be 1 over 11. Makes sense, doesn't it? Pretty easy stuff. Now, tonight's homework assignment, 7 through 13, is really just, you should be able to find dx over dy, find that derivative, and then from there, right, do the reciprocal. Okay? And that should be tonight. Then I want you to also watch that video, Slopes of Inverses, and that'll basically allow you to be able to do those ones that you can't find the derivative of directly. So that's all that there is. It just to prove to you, I think I did this for you on Friday, but just to prove to you that it does work, I can easily find the inverse of this and do its derivative as well. And that's really where you're headed with this. So just throwing it out there. That's all I want you to know from today.